Okay, guys, sorry, that was super frustrating. I don't know what happened to my computer while we were writing this equation down, but let's continue writing down our copper sulfate reacting with barium nitrate. So we had the copper breaking down into its ions because it was aqueous, the barium and the nitrate breaking down into the ions because it was also aqueous. I should put aqueous here with the barium. And we had the copper 2 nitrate breaking down into its ions because it's aqueous, and we're going to have the 2 nitrate ions. But the barium sulfate is solid, so we are going to keep that together. Okay, so hopefully you see that there are some repeaters that we can get rid of. So we can get rid of the copper, and we can get rid of the nitrates, because they repeat on both sides. So our net ionic reaction is going to be what's left. It's going to be the barium and the sulfate going to make the barium sulfate. So we have our barium ion reacting with our sulfate ion, and that's aqueous, and that is going to react to produce our barium sulfate solid precipitate. Okay? All right, one more example. Chromium 3 iodide. So the chromium is going to be a positive 3. Iodide is a negative 1. It's on our halogen. And then we have ammonium. Oops, I can't write today. Ammonium, we have NH4, and that's a positive 1. And then acetate, we have C2H3O2, or you could write it CH3COO. Those are the two ways that you can write acetate, and they are both negative 1. It's the same thing. Okay, so chromium being a positive 3 and iodide being a negative 1, we're going to need 3 iodides on there. Now, is that soluble or not? We don't have a chromium rule, but we do have a halogen rule. Iodides are soluble except for silver, mercury, or lead. Chromium's not any of those, so it is soluble. And then ammonium, positive 1 with a negative 1, we're going to need 1 of each. C2H3O2. Now, all ammoniums and all acetates are soluble, no exceptions. So that is going to be aqueous. Okay, now double displacement. So chromium is going to get together with the acetate. Chromium is a positive 3, and acetate is a negative 1. So I'm going to need 3 acetates, or that's a C2H3O2. And I'm going to need 3 of them. Now, all acetates are soluble, no exceptions. So that is going to be aqueous. And then ammonium is a positive 1, and iodide is a negative 1. So they're going to be 1 to 1. And all ammoniums are soluble, no exceptions. So, all right, aqueous, aqueous. So let's break down everything that's aqueous into its ions. So if I do that, I'm going to have my chromium plus 3 aqueous, plus 3 iodides, negative 1 aqueous, plus, we've got to balance this. Let's see. I'm going to need to triple this, and I'm going to need to triple this. Do you guys agree with that? I'm going to need to have 3 ammoniums plus 1 aqueous and 3 acetates aqueous, and that's going to go and make chromium plus 3 aqueous plus 3 acetates aqueous plus 3 ammonium groups, aqueous, and 3 iodides, aqueous. Okay, we can cancel out everything that repeats. So do you guys see things that repeat? My chrome repeats, my iodides repeat, my 3 ammoniums repeat, and my 3 acetates repeat. Everything canceled out. So what do I write for my net ionic? Do I have anything really reacting here and creating a precipitate? No. And because nothing creates a precipitate, we write NR, and that NR signifies no reaction. Okay? All right, so have a great time using your solubility rules to figure out your net ionic equations and figure out what's going on. Thanks. Bye.